In the previous two videos, you've seen that first of all what pressure is. So pressure is the force per unit area, and then in the second video you've seen that all fluids, which includes liquids and gases, apply a pressure. So why do they apply a pressure? They apply a pressure due to their weight, because weight is essentially force, right? I've told you that because I'm standing here, I'm applying some force on the ground which is equal to my weight, and that force also results in some pressure because my feet have some area, and if I divide the force that I apply downwards, which is my weight, by the area of my feet, I get the pressure that I exert on the ground. So that is pressure. Now we have another fluid that is present all around us. What is that fluid? Well, remember, fluid includes liquids as well as gases. So we have a gas around us, right? It's air. Air is a combination of various gases like oxygen, nitrogen and carbon dioxide and other gases, and we have atmosphere around us, and therefore atmosphere should also apply some pressure. How? Well, we have so the atmosphere extends to a particular height above us, and therefore the column of air above me has some weight, right? Because Earth is pulling the atmosphere downwards, because atmosphere has some mass, and therefore it has some weight, and because it has some weight, it is also exerting a pressure on the ground and on me, on everything around us due to its weight. But the question is, if the atmosphere extends up to 100 kilometers above me, so if there's such a large column of air right now on my head, why don't I get crushed under the weight of that column? Well, the answer to that is that because there is some air inside me, inside my lungs, inside my other cavities, and that air is applying an opposite pressure onto my body, and that is what is keeping me intact, or else I would have crushed under the weight of the atmosphere. And to prove my point, I have this bottle here. So right now there's air above it, around it, which is applying a pressure on the walls of the bottle, trying to crush it. But because there's air inside this bottle, that air inside the bottle is pushing the bottle outwards, and that's why the bottle is not getting crushed. But what happens if I remove the air from inside the bottle? Well, then we can see that because there is no air inside the bottle that is pushing it outwards, the atmosphere should be able to crush the bottle. So how can I remove the air from inside the bottle? Well, the simple way is to just suck it out, and if I suck all the air from inside this, there will be no air inside it pushing the bottle outwards, and therefore the atmosphere can easily crush this bottle. And we can just see that here by when I remove the air from inside the bottle. See, I'm not pushing the bottle in any way. I did not touch the bottle. This bottle has been crushed due to the weight of the atmosphere, due to the pressure that is being exerted by the atmosphere. And because there is very little air inside the bottle that is pushing the walls of the bottle, that's why the bottle was easily crushed by the atmospheric pressure. But if I open the bottle, now I can push in air, which can push the walls of the bottle, and the bottle will regain its shape, just like this. See, now there's air inside the bottle which is pushing it outwards, and there's atmospheric pressure outside the bottle which is trying to crush it. But because both of them are applying equal pressures, the bottle is intact. But if I remove the air from inside the bottle gets crushed. See, simple. So that is atmospheric pressure, and atmospheric pressure is acting on all objects. It's acting on you right now. It's everywhere. And as we go higher, the column of air, because right now there's a large column of air above my head, but if I, let's say, go on top of the Mount Everest, there the column of air above me would be slightly lower because I'm on a higher place. So there the atmospheric pressure is lower, and that can be felt if you go there, because it will be difficult for you to breathe because there is not much air around to breathe. So that's the basic idea of atmospheric pressure. And yeah, that's basically it for this video.